Hey everyone, go ahead, picture a slice of bread. You look at the label, right? It says, I don't know, protein, 4 grams. But have you ever really stopped to wonder how they know that? It's not a guess. Let's dig in.
Yeah, it's a fantastic question, right? Because it's not some wild guess or an estimate. Nope. It's the result of a super precise, surprisingly old scientific process. So today, we're going to be detectives. We're going to follow a piece of bread all the way from the loaf into the lab and figure out exactly how that number comes to life.
Okay, here's the game plan. First, we'll look at the official rulebook. Then we'll see how they turn a loaf into a lab sample. After that, it's a deep dive into the chemistry, how they find the clue, and finally, how they crack the code to get that final protein number. Let's do it.
Right, so first things first, to get an answer you can trust, you need a method everyone agrees on. I mean, you have to make sure that a lab in California and a lab in New York would get the exact same number from the exact same loaf of bread, right? That's where the official rulebook comes in.
And that rulebook is created by organizations like the AOAC. That's the Association of Official Analytical Collaboration. Bit of a mouthful, we'll just call them the AOAC. They are the ones who write the official playbook that scientists have to follow. Their entire job is to make sure that when a label says 4 grams of protein, it means exactly that, no exceptions. And here's the crazy part. Check this out. This isn't some brand new high-tech thing. The core chemical test we're talking about, it was put on the books back in 1920. Seriously, the science behind this is so solid, it's been the trusted standard for over 100 years. That's wild. Okay, so where do we even begin? I mean, you can't just shove a slice of sourdough into a test tube, right? The first thing you've got to do is prep the bread. You need to turn it into a perfectly uniform sample so you can test it accurately. Let's see how they do it. So, the official method, which by the way goes all the way back to 1926, is super specific. It's a 4-step deal. First, you cut the whole loaf into really thin slices. Then you let them air dry in a warm room till they're super crisp. You got to get rid of all the water because that would totally mess up the chemistry later. Once it's bone dry, you grind the whole thing, the entire loaf, into a fine powder. That way, any little pinch you take is a perfect miniature version of the whole loaf. Oh, and here's a little fun fact for you. If it's raisin bread, the rules say you have to use a food chopper instead, just to handle the fruit. They thought of everything. All right, we've got our magic bread dust. Now the real fun begins, the chemistry. See, to find the protein, we actually have to hunt for one of its key building blocks, nitrogen. And to find the nitrogen, well, we have to destroy everything else. The whole thing is built on this genius bit of 19th century chemistry called the Kjeldahl method. It's like the gold standard for finding nitrogen in anything organic. We're talking soil, fertilizer, and yep, our bread. So phase 1 is called digestion. And you can really think of it like a chemical furnace. The whole idea is to use some seriously powerful acid and a lot of heat to just burn away everything. The carbs, the fats, all of it. We obliterate everything except for the nitrogen, which we trap and hold on to. So let's meet the key players in this little chemical drama. First, you've got your sample, a tiny, perfectly weighed bit of that bread powder. Then you bring in the big guns, sulfuric acid. That's what does all the digesting. To make things go faster, you add a catalyst, something like mercury. And finally, you add potassium sulfate, which actually raises the boiling point, making the whole reaction even more powerful. So they boil this whole concoction, sometimes for hours, until the liquid turns completely clear. That's the sign. That's when you know the digestion is done. And at this point, every single atom of nitrogen from the protein in that bread is trapped, safe and sound, as something called ammonium sulfate. It's locked in, and it's ready for phase 2. Okay, so we've trapped the nitrogen. Awesome. But now what? How do we actually count it? Well, the next phase is this really slick 2-step move to pull that nitrogen out and measure it with insane precision. Now, this might look a little complicated, but it's actually a really elegant process. First, they add a chemical that forces the nitrogen to escape as ammonia gas. Then, right away, they capture that gas by bubbling it through another special liquid that grabs onto it. And then comes the magic part, a process called titration. The easiest way to think about it is like a super precise counting method. A scientist adds another chemical, drop by drop by drop, until a color suddenly changes. And that color change tells them exactly how much ammonia they captured. And this is the key takeaway, right here.
The amount of that chemical they added tells them the exact amount of ammonia they captured. And since all the nitrogen was turned into ammonia, we now know precisely how much nitrogen was in that original little pinch of bread powder. We have our number.
Boom, we've got the nitrogen value. We are so close. We're on the home stretch. All that's left is a little bit of math to turn this chemical clue into the actual protein number you see on the package.
So the numbers from that titration get plugged into this big, official-looking formula. I know, it looks a little scary, but don't worry about it. Its job is actually super simple. It just takes all the measurements from the experiment and spits out one final, very precise number, the percentage of nitrogen in our bread. But wait a minute. Hang on. We measured nitrogen. The label doesn't say percent nitrogen, does it? No, it says grams of protein. So how do we get from one to the other? What's the final piece of the puzzle?
Well, this is where something called a protein conversion factor comes in. It's pretty simple, actually. Proteins are made of amino acids, right? And all amino acids have nitrogen in them. So scientists figured out a long time ago that, on average, a certain amount of nitrogen equals a certain amount of protein. It's a reliable ratio. Now, that magic number, that factor, it's a little different for different foods. You know, milk has one, eggs have another, but for things made from wheat, like our bread, the official AOC method gives us the specific key we need to unlock the final answer. And that number is 5.7.
So the final calculation is almost beautiful in its simplicity. You take that nitrogen percentage that we worked so hard to find, you multiply it by 5.7, and bam, there it is, the percentage of protein in the bread. That's the number that goes on the label.
And that is the entire journey. Think about it. We went from a simple loaf of bread all the way through drying, grinding, being dissolved in acid, and a super precise chemical measurement, all just to get that one single, scientifically proven number you see on the nutrition label.
So the next time you pick up a loaf of bread and glance at the label, you'll know. You'll know that behind that little number for protein, there's a century of really careful, rigorous science. It's a whole process designed to do one thing: give you confidence in the numbers you're reading. Kind of makes you wonder, doesn't it? What other secrets are hiding in plain sight on that nutrition label? What kind of science is behind the number for fat or fiber? Really makes you think. Thanks for digging into this with me.